Okay, so number 5, we're going to do another find the area and perimeter. I like to do area first because that generally doesn't require so much of the technology. So we want to find the area and perimeter of the region bounded by sine x and cosine x on the interval 0 to pi over 2. So sine x, let's see, is starting at the origin and it's increasing, and by the time we get to pi over 2, its value is going to be 1. So we're coming up, we're leveling off right there. For cosine x, we're doing kind of the opposite. We're starting at 1, we're headed down, we cross right at pi over 2. So if we're looking for area bounded by sine and cosine, there's several regions that people will look at, but that's going to be this and this. And I'm even going to color code because I'm seeing already that the top curve switches. So y equals sine x is the top curve from 0 to pi over 4. Hopefully we recognize that if we're looking for when on the unit circle our x coordinate and our y coordinate are equal, it's right at pi over 4. And where's this? Y equals cosine x is the top function from 0 to pi over 4. So there's my picture, which means when I go to do area, I'm going to go from 0 to pi over 4 with cosine x being the first function. And then I'm going to go from pi over 4 to 2 with sine x being the first function. I have an extra d. Okay, so when I go to integrate, I guess I'll stick with my colors now that I started with. Antiderivative of cosine is sine x. The antiderivative of sine is a minus cosine, so that actually becomes plus. And we're going to go from 0 to pi over 4 with that one. And then, let's see, antiderivative of sine is a minus cosine. Antiderivative of cosine is a sine, and we're going to do that from pi over 4 to pi over 2. Did I just write this wrong, or did I totally flake out on you? Okay. So, first thing, we need sine of pi over 4, which is 1 over the square root of 2, or if you've memorized it as root 2 over 2, that's fine. And cosine of pi over 4 is exactly the same. And then we need to plug in 0. Sine of 0 is 0. Cosine of 0 is 1. So here's our f of b minus f of a. And then similarly on the second one, we're now starting with the pi over 4, so we're going to get a negative 1 over root 2 minus 1 over root 2. And then we're going to subtract off what we get when we plug in pi over 2. When we plug in pi over 2, cosine is 0. Sine is 1. Okay, so what do we have? We have we have a 2 over root 2, which is what? Just a root 2? Root 2. Here, hold on, my brain's not working. Does that simplify nicely? Okay, so we get a 2 on the bottom and 2's cancel. Yeah, that's actually just a root 2. I'm not hugely concerned about whether or not you spotted that, but it does simplify nicely. And then let's see, this is a minus 1. This is a minus 2 over root 2. And this is a plus 1. Oh, wait a minute. These shouldn't be zeroing out if we set them upright. Did I get something in the wrong order? Minus, minus. Oh, pause. Okay, let's see. Cosine x minus sine x from 0 to pi over 4. I think we got that right. Sine x minus cosine x from pi over 4 to pi over 2. I think we got that right. So derivative of sine is cosine, derivative of sine is cosine, derivative of cosine is minus sine, derivative of cosine is minus sine. Okay, and did I plug in anything in the wrong order? Ah, I did. Okay, sorry guys. Let me backtrack to right over here. I totally plugged in the wrong order. We're supposed to first plug in pi over 2. So we said cosine of pi over 2 is 0. Sine of pi over 2 is 1. And then we should be subtracting off what we get when we plug in pi over 4. So cosine of pi over 4 is 1 over root 2, as is sine pi over 4. That should work out more as I expected. So getting 0 here is absolutely what should happen if we just straight up integrate one minus the other from 0 to pi over 2. Those two areas do cancel each other out, the pink and the blue. But the point here is to not cancel them out, it's to add them up, and we carefully split this up so that would happen. So it's very concerning if that's not what's happening. So now, let's see what we're getting. Now I'm seeing 2 over root 2 minus 1 still, and then I have minus 1 plus 2 over root 2. And that means I get 4 over root 2, which again, you can actually simplify that. I'm not hugely worried about if you do, minus 2. Okay, so there is my area calculation. Again, it is your job to figure out if the two cross, and then you have to deal with that yourself. To calculate my arc length, I'm going to say, okay, so I need to integrate from, oh, so this is an interesting one. I have a weird, if I want my perimeter, I need to get this entire blue segment here, because whether it's the top or the bottom curve, it's part of the perimeter of that funny kind of butterfly shaped region. So we're going to go from 0 to pi over 2, square root of 1 plus the derivative of cosine, which is minus sine, but then we square it, so it's just going to be positive. And we don't really have to split these up, but just to show the pieces, here I'll even do colors. So that gives us that blue stretch of curve. And then we need to do the same thing for the sine function. So we'll do the square root of 1 plus the derivative of sine is cosine. So this one's going to be cosine squared. And if you spot that those two are actually the exact same length on that region, great, use it, that's fine. You could just double one of these and you'd be set. Just reflecting either one off pi over 4, across pi over 4 makes it identical to the other. There is one thing that we're missing. We're supposed to get perimeter, so we need to not ignore these two edges, which both have length 1, so we need to be adding 2 to this. And this time I did plan ahead a little better, and I already plugged the integrals into my calculator, and I got 3.82 plus 2, so total perimeter is about 5.82. Thanks for watching.